and stomach. And example would be alcohol. If you don't want it to be absorbed, what do you do first? Drink milk. You know that? What else? Somebody else said something. Eat meat. Did I hear that? I don't know. But if you're going to drink milk to prevent this, be sure that it has fat in it, because that's the reason you take the milk, right? So you can't absorb it. Now, some drugs, very few drugs are absorbed in the stomach. What's the common one? Aspirin, right? So a drug. But you do wonder, sometimes they tell you to take your aspirin with a beverage. Would you take it with fat milk? No. But basics to learn. So that gives you an idea of why you have your stomach. So let's go on to our small intestine. And the small intestine will extend then from our pyloric sphincter. At what vertebral level is our pyloric sphincter? It will begin with our pyloric sphincter at, is it T1 or 2? We'll put T1 and check it. And we'll end at the ileocecal valve. Ileocecal valve. How long is that? About 20 feet. Have you ever seen your small intestine stretched out? Pardon? Not yours. I need 2 people. It took us a while to get this small intestine. Somebody? 2, thanks. I know you'll cooperate. All you do is go across the stage and take out your small intestine. Isn't that amazing? That all of that is twisted to fit in here. Oh, I used to do that. We called it, should we do it and fall on the stairs? That'll be dramatic. That's a first. We do this each year to show, just so you can get an idea of how long your intestine is. Okay, we can wrap it up. Thanks ever so much. Yeah, they get a hand for that. That was nice. We'll try jump roping at some other time when we don't have stairs in front of us. Thank you. All right, this small intestine then is divided. It has 3 divisions that carry on different functions. First one is the duodenum. What does duodenum mean? It means 12 fingers. You put 12 fingers side by side and you have 10 inches. So it means 12 fingers to equal 10 inches. And then we have the duodenum. And the duodenum means what? You'll never guess. Empty at death. And it'll be about 8 feet. And the third part is what? The ileum. You spell it with an E or an I? An E, right. Ileum. I didn't say begin with an I. It's the E here, because with your... All right. The ileum. This is really strange. I don't make up these words, but it means groin. essentially the same that the other ileum means. So this means groin. And what has it got? It's got about 10 feet. So it gives us roughly 20 feet. These are the figures that you get. So different things are occurring in different parts. Let's look at the small intestine then and see how it's built to carry out its functions. So we'll have the mucosa is thrown into folds. And on it we will have finger-like projections, increasing surface area tremendously here. And so forth. And these projections are the villi, collectively, singularly, a villus. And they will have what used to be called with the light microscope a striated border. On their surface. Just do a little striated border here. Which really, with the electron microscope, turned out to be microvilli, increasing the surface area more with an EM for electron microscopy. These will be microvilli. And to show one important function related to them, they're filled with acid phosphatase, have acid phosphatase, and that will then enhance the absorption of calcium. We'll just put AIDS, absorption of the calcium ion. So very important ingredient. Now, with these villi, at the base, we have what are called the crypts of Lieberkühn. Crypts of Lieberkühn are down at the base. And why is it important to know these? They're cells called the cells of Paneth in the crypts of Lieberkühn. Has cells of Paneth. And the cells of Paneth then have enzymes for the digestion of carbohydrate. Enzymes for carbohydrate, fat, and protein digestion. What else is important about the crypts of Lieberkühn? That the cells that line the villi are being produced at the crypts of Lieberkühn. sort of like a conveyor belt being produced in the crypts. Produced in the crypts. And they're produced at the rate of about 3 or 4 days. They're renewed. Why do some of us like this? Because sometimes people say, well, how old are you? I say, parts of me are only 4 days old. And that's true, right? And doesn't that feel good? Right? Anyhow, we can have lots of fun with the body when you have the facts, and that's a fact. So, what else do we have here? In our duodenum, we will have glands. And the glands are called what? Brunner's glands. And what's the purpose of Brunner's glands? We've just put in all of this acid into the duodenum with a pH of 1. We've got to neutralize that. So right in the duodenum, you have Brunner's glands to neutralize the HCl and give us a pH then of about 7.6. So very important. And that's one way when you're having your examination and you have a piece of tissue from the small intestine, just look for Brunner's glands and you know what part you're in. So another part of the small intestine, which has a varied characteristic, is the ileum. And it will have masses of lymphocytes. We've learned this before. What are they called? Peyer's patches. These are Peyer's patches. We've mentioned them previously. And they are there to fight any bacteria that is coming in. We'll just put fight bacteria. And that tells us a little about the structure of the small intestine. We'll see if there are other things that we should mention. No, that's essentially it. But I did want to share something because I went to the web this morning to find out a little bit more about the GI tract. Excuse me, the GI tract. And it says that the HCl releases vitamin B12 from the food. I've never heard that before, have you? And then it said, you know where it's being absorbed? Most of the absorption in the small intestine takes place in the duodenum and jejunum. So we'll put that down because that's a fact in all your textbooks. Most absorption in duodenum and jejunum. But with this HCl releases vitamin B12 from food. And it's absorbed in the ileum. Just to show we don't really know everything there is to know about the GI tract, even though there's a lot that's conventional. So we'll put absorbed in ileum. I mean, we can look up new facts all the time, but you won't get your basics. And so I try to stay to your basics and be sure you have those well, and you'll be building on them. And what happens when you don't have vitamin B12? You become anemic and fatigued. Do you feel a lot of you have B12 deficiency now? So, lack of B12, anemic, and fatigue. But it is rare because B12 is found in eggs and milk and many of the common foods that we should be eating every day. But I thought the fact that it was being absorbed in the ileum was just of interest, possibly. Now let's move on to the large intestine. Why is it called large intestine? You've just seen we don't have room for another intestine as long as our small intestine. It's large in contrast to small in diameter. Larger than small intestine in diameter. So how long is it? It's only about 4.5 feet long. Now, what can we say about the large intestine? It has several parts. First, we'll just list them. The cecum, the colon, and it's the colon that has its various parts. It has the ascending part, the descending part, and no, we've got to put a transverse part in first. A transverse, then a descending, and then what's the last part? Sigmoid. Where did we have a sigmoid structure before? Pardon? The venous sinuses in the skull, right? Remember those, the sigmoid sinus. Here we've got a sigmoid colon, so it's S-shaped. That's all it's telling us. So the cecum will be a blind pouch. And it begins in the right lower abdominal quadrant. So let's just pretend this is our abdominal wall, divided in quadrants. We're going to start over here with this blind pouch. And we have the small intestine coming in here. So what did we call the valve? What do we call this valve? Ileocecal valve. And this blind pouch is my cecum. Its wall, like the ileum, is also filled with lymphocytes, many lymphocytes. And it has a small structure coming off of it. And we call that small structure what? The appendix. Have you had your appendix out? How many have had your appendix out? Not many. In our day, whenever you got any sort of pain in this right lower quadrant, they take out your appendix. But it's like the tonsils. It's filled with lymphocytes again. It has functions. But if it can't fight them, so we see the little appendix there in the, how do you tell somebody exactly where the appendix is if it's in its normal position? From surface anatomy. So from surface anatomy, you find your anterior iliac spine, anterior iliac spine, and you draw a line over to your umbilicus. Just have it here. And a third the way along, you have a point, McBurney's point. McBurney's point. So you figure out where it is, go deep, and that's where your appendix is. I'm going to backtrack just a little minute to cover, I didn't know where to put it in, but we've got to discuss the peritoneum. And then I'll come back to the appendix because we'll say what happens if the appendix bursts and puts all the contents from the cecum out into your peritoneal cavity. So let's go to the word peritoneum for a moment and then come back to our GI tract. We've had the pericardial sac with parietal and visceral pericardium. We've had the pleural sac in the thoracic cavity, the pleura, with parietal and visceral pleura. And now we have the peritoneum for our abdominal wall. And viscera. So the abdominal wall, what are you going to line it with? You're young anatomist, you've got to give it a name. What are you going to name the peritoneum lining the abdominal cavity? Can't hear you. Parietal peritoneum. Right, so the abdominal wall is lined with parietal peritoneum. And the organs, the viscera, are covered with what? Visceral peritoneum. So what do we call the space between the two? Peritoneal cavity. So in here we have the peritoneal cavity. So obviously you don't see much of it because the organs are all piled on each other, but it does exist. The simplest way to do this, very, very simple cartoon, is to make this our abdominal cavity, and we've got the abdominal viscera going through it in just this form. And we'll find then that the parietal peritoneum, got to get a different color chalk. Would be lining the cavity. That's our parietal. And the visceral we'll just leave as green because that's lining the viscera. But the point is that I've just done this in very cartoonish fashion because when you've got 20 feet, this whole thing is wound in here, and you certainly don't have a cavity like this. But I wanted you to see accentuated that it does exist, so that if I get a burst appendix that can happen, the content can go into the peritoneal cavity. And if it's not treated immediately, death can ensue because you've got feces then in the peritoneal cavity. In extreme case, feces in peritoneal cavity. Sometimes you give worse scenarios because it makes it dramatic to know that there is a peritoneal cavity, even though you don't see it this way. And this can be death. Did anybody ever had a burst appendix or know anybody who did? You did. How long did you have it before it was treated? You don't know? Uh-huh. All right. Well, she's here, so it didn't take too long, right? Now, that gets us our cecum. Let's follow our ascending colon. We'll take it up. This now is ascending colon. What we're essentially doing with this path is making a picture frame around our abdominal wall. And so we have the ascending colon that'll go into the transverse colon, all continuous tube, just different locations. And then it'll turn and go descending. And when it gets down to about the crest of the ileum, it will turn over and become sigmoid. To the midline, it's got to reach the midline, and then go into the rectum and into the anus. So we have ascending, transverse, descending, and sigmoid. Just to give the dynamics of them, sigmoid's coming right below the stomach, across. And when we had one of our guest speakers once, he said a patient that he saw had the seat belt tight around the waist when he had an accident, and it just crushed that whole transverse colon. So as a abdominal surgeon, he just took out all the crushed, and he just connected the ascending to the descending. A word about the sigmoid. Feces are stored in the sigmoid colon. They're not stored in the rectum. Feces stored in sigmoid colon. You hear a lot about cancer of the colon these days, having colon cancer. Which part do you think cancer is most prevalent? Sigmoid, right? Cancer most prevalent. In sigmoid. what are its functions, and then let's look at its inner structure. Why do we have a large intestine? Well, first, it will be receiving the undigested and unabsorbed food. Receives undigested and unabsorbed food. And something that you may not have known is that here is where water is absorbed.